Okay, we're going to take a look at finding the area of a non-right triangle given two sides and the included angle. Okay, two sides and the included angle. So included means in between. I know there's three formulas here. The way I just like to think of it is 1/2 side, side, then sine of included angle. If you can remember it like that, then all three formulas are really the same. Included means the one between. So A is between B and C. B, angle B is between A and C. There's my two sides, included. C is the angle between A and B. So there's my two sides and the included. Now this is really coming from, it's going to give you an old geometry lesson mixed in with the trig. You should remember that in geometry, a long time ago, I'm sure, is 1/2 base times height, just a basic formula for the area of a triangle. And if it's a right triangle, you would have a base, then a height. You know, here, if I knew what this height was right here, then I could work it, but I need another value. So if I don't know anything on the inside, I'm going to ones like this, okay? So I'm not given a height. So let's look at where these came from. All right, I'm just going to look at the top one here. So here's A. All right, here's C, here's B. So my two sides are B and C. So this would be the base, okay? This would be the base. I'm going to call this H for the height. So if I knew the height, if I actually knew what that value was, if I knew it was a 7, well, it's 1/2, 7 times whatever that base is. But I don't know what it is if I'm given some kind of non-right triangle like this and I wasn't given the height. So let's kind of look at where it comes from. What you should remember is sine of A is opposite H over hypotenuse. So remember, looking right here, this is the opposite. There's the hypotenuse of this right triangle. That means the height is C sine A. So if I compare this back to the geometric formulas, the geometric formula was 1/2, I have BH, but it's really base height. So here, trig, 1/2, the base is B, and the height is, if I solve for H, C sine A, and there's where that top formula is coming from. We can do the same thing to create the other two because we build the right angle or right triangle off of the other one and so forth. Not much going on there. It's really the same thing if you just rearrange the letters. But there's where that's coming from. So I remember included angle. Two sides, included angle. So angle between. Outside of that, it's just putting the values in the calculator. So we just need to come up with our area. We've got to make sure that we're using our two sides and we're using the appropriate angle, whatever it is, A, B, or C that we need. So if I was given, if I was told find the area now let's go, say 1. A is 3, B is 4, and C is 40 degrees. So the first thing to check would be, is C included between A and B? In other words, is the angle in between? Okay? And a lot of times it's very helpful to just have some generic diagram up here, because then you can see C sitting between A and B. So here we just type it in. Area is 1/2 times 3 times 4 times the sine of 40 degrees. So, and we're in degree mode because we had degrees. If we were given a radian measure, we'd need to make sure our calculator is in radian mode or change it to degrees, whichever is easiest for you. So this would give me 3. I'll go nearest 100, so 3.86. Okay. That would be my area. And I'm not really worried about units. I mean, area is in units, but I didn't put any units on the problem. If I did, let's say I said that this was 3 inches, 4 inches, well then this would be inches squared since it's area or square inches. Now, if we've got some units, we need to use them. Let's get another one. Let's go. B is 1. C is 3. And we'll say A is 80 degrees. So my first check is A included? Is it between B and C? And it is. So area would be 1/2 times 1 times 3 times the sine of 80 degrees. Okay, and I didn't put units again, but let's say they're centimeters this time. So we'll say centimeters, centimeters. Okay. So here we would have 1.48. Again, I just went to the nearest hundredth, centimeters squared. Okay. For those pieces. Okay. Now let's change our look a little bit. I'm going to stay in degrees. No real reason other than my calculator sitting in degrees. So I'm going to say A equals 7, C equals 9, and then A is 59 degrees, and B is 21 degrees. A is 59, B. So this time I give you two angles with the two sides. The most important thing would be which angle's included, because the one that's included is the one I want to use. So I'm given A and C. If I look at my triangle up on the right side, the included angle is B. So that means that this is the one that I would want to use. I want that angle sitting in between. So now we're just operating the formula. Made sure we had the proper angle, the one we wanted. So A would be 1/2 times 7 times 9, sine of 21 degrees. So I've got to make sure I'm using the 21 since B is the included angle. Let's see what I get here. I got 11.29. And again, I didn't have units on there, but if we had units, we'd put the square unit. So in other words, if I had, say, feet squared, whatever the units are, okay, for that value. So this would be the value for the area. So we need two sides in the included angle. So angle was included. Angle was included. Wait a minute. Which one's included? Well, the B's the one included, the one between. So I need to use B, okay? Pay attention to if you have the included angle or not. So here's kind of going to go back to some other lessons that you've had. If you're not given the included angle, but you're given two of these angles, then you know what the third angle is because they all add up to 180. So for example, if I had given you A and C and you needed B, subtract from 180, you'd have the value of B, you're good to go. In cases where you're given two sides and an angle that's not included. So for example, let's say, we'll go back to this first one here. Let's say, just kind of give you an idea. Let's say I gave you A equals 40 degrees. Okay. Well, I look up there and I'm trying to, oh, wait a minute, see, A, here's my thought process. A is not between A and B. So this would be a case where if I have the two sides A and B, I need angle C. Now, since I was not given another angle, I can't just subtract from 180. That's okay, right? But I can still find angle C. What I would need to go through is using, this is going to go back to a previous lesson. So in this case, I'll say would need to use law of sines in this case, or you could even use a law of cosines to go find what angle C is in a lot of cases. Depends on what information you're given, but you can go back to that law of sines and figure it out. So we're not going to work through this whole process. You can look back at another lesson for the law of sines. But here comes that law of sines. If I wrote it out, it'd be 3 over sine 40 equals B over, not B, excuse me, 4. I know that's 4. Over sine B. Now, I need C, but I don't have side C, so I can't use that law of sine. So my goal would be go find B. Well, once I have B, then I have two angles. I can subtract. I've got C. I'm good to go to the area. So, most of the time we're given what we need, but if we're ever not, we can go back to one of those law of sines and figure out that angle that we're going to need. Sometimes we could go directly to it. So in other words, if I gave you, for example, C, all right. So if I gave you A and C, that means you need angle B. So I'm still going to go and find angle C first and then come back. So it depends on what you're given. Okay? If you're not given exactly what you need, then you could use law of sines to go find that angle or side. But we need two sides and the included angle to work these formulas. Two sides and the included angle.